Alrighty, people, we're finally here. The last question, the algebra contest. Let's get started with part A. You are asked to express this in partial fractions. Downstairs factorizes to x minus 1, 3 minus x. Equating coefficients. Add the two fractions first. If x is equal to 3, first term is gone. B is 1 by 2. Plug in x equals to 1. Second term is gone. A is also 1 by 2. And therefore, this is 1 by 2 by x minus 1 plus 1 by 2 by 3 minus x. Part B. Now you are asked to solve the equation. We don't know what k is, and seems like we are not going to find out what k is. So this is just going to be a ton of algebra. Obviously, the way to go is separable. Because otherwise, why would they give you part A? Using the result we have established earlier and replacing x with n. Integrate. Right hand side is going to be kt plus a constant. Multiply both sides by 1 by 2. By 2. And then simplifying this guy. Will give what you're looking for. Okay. Part C. Now you're then asked to isolate for n. Easy peasy. They also want us to express C as ln of P in the previous part. So I guess we're going to do that. Initially, 1,500 rabbits are infected. So this is the initial value. N is in thousands, people. So what we're given here is that n at 0 is equal to 1.5. And therefore, ln of 0.5 divided by 1.5 is equal to C. C is equal to ln of 1 by 3, or minus ln of 3. And therefore, we have this expression. It is always a good idea to double check your work, because 8 marks is quite a lot of marks to go around. And the fact it took me 5 lines of working out is a little bit suspicious. So keep that in mind. Part C. Now we can isolate for n. I'm going to raise both sides to the power e. Take your time, okay? This is e to the 2kt times e to the negative ln of 3. Isolate for n. So I'm going to multiply 3 minus n through both sides, isolate the ends, and then divide through. We'll see if this is what they're looking for. Okay, so we have a 1 in the denominator, so this is good. And I think that is pretty much it. Wait, hold up. Okay, look at the power again. We have power negative 2kt. So I suspect what they want us to do is multiplying both the top and bottom by e to the negative 2kt. The first term is going to be 1. Over here is going to be the same. And then we're going to multiply everything by 3. And now everything has the right exponent, and we have plus 1 over here. Every single value here is also an integer. So we're good to go. The manipulation is a little bit tricky, and I can see how a lot of students would have lost at least 1 mark because of this manipulation. Part D. According to Rowan's model, the number of infected rabbits approach a limit L over the long term. Find the value of L. So, this is a logistic model for those who are not aware. But for this question, all you need to know is taking the limit as t tends to infinity of n of t. Now, I can see why they are doing this. As t grows, e to the negative 2kt is going to go to 0. K is positive constant. So, this means, if I may, I'm going to bring it up here. This is going to go to 0. This is going to go to 0. We will get 3 divided by 1, or 3 as the final answer. So yeah, this is the end of the AAHL Paper 1 for Time Zone A in May 2026. Not a hard paper, but surely there's a lot of algebraic manipulation required to get full marks on this very last question, the algebra contest.